Well, thanks, Thomas, for the introduction. Before we begin, let me tell you why I decided to talk about the topic today. A few months ago, a colleague asked me if I could help him decide how to implement a new solution in our internal data warehouse. Since we were both in the office, we sat together and started to talk about it. What seemed like a 5-minute question went went pretty fast into a deeper discussion. And so about an hour later, I had to rush back to my desk and jump into my next meeting, one that I nearly missed because I was so caught up in the discussion. That moment became the inspiration for today's session. It reminded me how important and sometimes how challenging it can be to choose the right Power BI model type. And that is exactly what we are going to talk about today. Mastering Power BI model types, how to choose the right approach between import, DirectQuery, and composite models. My name is Gregor Prohaska, and I'm happy that you are joining my session. I work as an operations manager at Cosmo Consult, and I do have some years of experience. If you're interested in the exact number of years, feel free to check out my LinkedIn profile and do the math. We are all somehow data analysts in a way. On a personal note, I'm a father of 2 beautiful sons. I define myself as curious by nature, and most of the time I try to don't take myself too seriously. But this session, however, I do take serious, and therefore, of course, I've prepared an agenda. So first, we will cover some important terms and concepts. Then we will look at the base model types, and after that, we will move on to the more complex composite models. At the end, I will summarize the key differences and give you my view on which model type makes sense in which situation. And at the end of the session, you will get a link to my slide deck, so you don't have to take any screenshots, and you can concentrate fully on the presentation. So let's make sure we all understand the most important terms and concepts and jump right into the concept of analysis services engines. The analysis service engine is the brain of Power BI and consists of 2 components, the formula engine and the storage engine. The formula engine is responsible for the more sophisticated parts of the query execution. It builds the query plan, it evaluates the DAX logic, and handles most of the complex calculations. One important thing to keep in mind is that the formula engine is single-threaded, which means it processes tasks sequentially rather than in parallel. That is one of the reasons why complex DAX logic can become a performance bottleneck in your solution. The storage engine, by contrast, is responsible for fetching the data from your data stores and performing simpler operations such as scans, materialized joins, and basic aggregations. The storage engine itself comes in 2 variances. There's the Vertipack engine, which works on a compressed in-memory data, which is an in-memory database, and the DirectQuery engine, which sends the requests directly to the underlying source system and translates the syntax. Understanding how those 2 components work together is key to understand why some models perform so well, while others might struggle with the performance. Which brings us to the next topic right away, performance. When we talk about performance, we should distinguish between data latency and query latency. Query latency describes the period it takes until a user gets a response to a request. So this is an interactive experience. For example, they change a slicer, apply a filter, click on a visual, and then they have to wait till the report is refreshed. Since the user have to actively wait till the report is refreshed, till something has happened, we do get feedback most of the time quite soon if that performance degrades. Data latency, on the other hand, is the time between the creation of the data and the moment that the data becomes available for querying in Power BI. In many scenarios, this refresh takes place during non-working hours, and therefore a degradation of the performance may not be noticed immediately. So that's the reason why most often we talk about query latency or query performance. Both dimensions compete with each other. If you optimize for one side, you pay most often a price on the other side. The definition of an acceptable latency is an important step and can have a significant impact on the decision which model type to choose. In our project, we decided that the data latency of up to 8 hours is acceptable for that choice. And we were confident that we can meet this criteria with every available model type. Now let's focus more on the structure and start with the layer where all comes together, the semantic model. A semantic model is the logical layer between your raw data and your reports. It gives us a business-friendly view of the data. It defines which tables are in the model, how they are related to each other, and which measures, hierarchies, and even formats are defined within the model. Somehow you can think of it as a container that holds everything together. And once we are talking about semantic model, the next step is to talk about what happens inside them, which brings us to the source group and relationships. Before composite models were introduced back in 2018, things were relatively simple. There were only regular relationships and one source group in each semantic model. Everything was fine. Everything was easy. That changed with the introduction of composite models. Once you combine multiple data stores in one semantic model, Power BI needs to know which tables belong together. And this is covered in the concept of source groups. So each data store belongs to one source group. Within a source group, relationships are handled like we are used to. But across source groups, Power BI uses limited relationships. And as the name already suggests, limited relationships do come with significant limitations. They do not propagate row-level security. You cannot use a DAX function like related. The joins are not materialized and have to be resolved at query time by the formula engine, which can lead to significant query performance issues. And last but not least, there's no blank element created on limited relations for if you have an issue with your referential integrity. So those are all things we usually take for granted in a Power BI model because they are granted in a regular relationship. But in limited relationships, they are gone. As a side note, limited relationships can not only apply if you're introducing a composite model, if you're introducing different source groups, it can also be introduced by a many-to-many relationship. So that's the reason why you should be careful if you're using many-to-many relationships within your Power BI model. Last but not least, let's go to the structural side of semantic models. Let's go to storage modes. Storage modes are tightly connected to the model types available in Power BI. While a model type defines the structure of a semantic model, storage types define which storage engine, so Vertipack engine or DirectQuery, is used for the individual table. So you define it on a by table basis. There are 5 storage models available in Power BI, 2 base types, import and DirectQuery, 2 variations of those, hybrid and dual, and the latest one as Direct Lake. With the exception of hybrid tables, we will discuss all of those storage modes later on in more detail. Now that we have the terminology in place, we can finally move to the actual model types. So let's start with the base models. There are 3 base models: import, DirectQuery, and Direct Lake. Direct Lakes comes in 2 different flavors: Direct Lake on OneLake and Direct Lake on SQL Analytics Endpoint. The SQL Analytics Endpoint was the first version of it, and the on OneLake version is now the new default version. What all base models have in common is this: there can be only one storage type in use. So that means all tables have to use the same storage type. That means import models use import, DirectQuery models use DirectQuery, and Direct Lake models use Direct Lake. Let's move on to the most widely used model, the import model. For each model, I will present you a high-level perspective about the roles of the data source, the middleware, and the analysis service engine. This principle will follow up with all the others as well. In an import model, the source system mainly provides the data at the time when the data is loaded into the semantic model. Power Query, in the middle, acts as an ETL layer and reads the data, transforms it, prepares it, shapes the form. It is used afterwards in the Power BI model or in the semantic model. After that, the data is handed over to the Vertipack engine, which compresses the data and stores it in memory and keeps it ready for your queries. It's sitting there and waiting. In simple terms, the source provides the data, Power Query shapes it, and Vertipack stores it. One of the biggest advantages of an import model is that it is supported by all connectors. Furthermore, it uses the Vertipack engine, which gives us very, very fast query performance, and it separates the refresh and the query workload, which protects, in a way, your data sources from excessive queries. From a security point of view, you have to define your security within the semantic model. The downsides are that you have to be aware about the storage limits and the limits on your scheduled refreshes. But those depend on which license or which capacity, which workspace type you are using. So on a premium workspace or a fabric workspace, you have other limits than on a pro workspace. Import mode is extremely strong in query performance and flexible source-wise. But that comes at the cost of having to move the data and refresh the data. This was, of course, one of the model types we suggested for our new project because we are used to it. Most of our projects or most of our semantic models we are using in the company are using import mode are of the type import model. But now let's look at the opposite approach, DirectQuery. DirectQuery works very differently. Here, the source system has much more responsibility. It not only provides the data, it also does much of the preparation and calculation. Power Query is mainly an interface layer in the middle and passes messages from the data source to the analysis service engine. The DirectQuery engine translates Power BI queries into syntax of the source system and sends it to the source system. So instead of storing the data inside Power BI, we push the work back to the source system. That changes, of course, the strengths and the weaknesses of the model. One major advantage of DirectQuery is that the data stays at your source and it's always up to date. Furthermore, there's no model size limit inside Power BI. The model size is only limited by your data source and the performance the query can be answered. Contrary to the import model, you could use source-side security. So that means you could leverage any security which is already implemented on your data source. But you could still create your security model within the semantic model. On the other hand, you do have limited DAX support. For example, there are no calculated tables available. And you can only use one database, one data source in your model. So DirectQuery is strong when data freshness matters. If your data latency has to be as low as possible. But it is weak in your query performance because you have always to transfer the query to your source system and back. Since the data freshness was not a concern, as I've mentioned before, we sorted that type out of as an option for our new model, which we were to create. So now let's come to the latest member in town. It is so new that there are constantly new features are available. Just with the pre-release of Power BI Desktop, Microsoft announced the rollout of unmaterialized calculated columns of Direct Lake. I did this presentation as a training session months ago, and I told everybody, hey, there are no calculated columns. Now they are available, even though not in my tenant yet. So they are not there globally. From an architectural perspective, the most obvious change is that there's no Power Query involved. At least we can't do anything with Power Query anymore. Here, Fabric takes over the part of Power Query. Instead of loading the data directly into the semantic model and storing there, all the data sits in your lakehouse or warehouse. Similar as in the import model, the data sources do only provide the data and do not have to do anything else. The Fabric layer handles the work. It reads the data, it transforms the data, it compresses the data, and it stores the data. The semantic model works on top of that. It caches the results and maintains its own data store, which is refreshed in a process which is called reframing. So in some ways, it behaves similar to import mode, but with a different storage and processing setup behind it. Like the import models, Direct Lake also uses the Vertipaq engine and separates the data preparation from query execution. The model and the table size limits are defined by your Fabric capacity, and you could use one lake security, which is just went generally available this week. But there are still some feature limitations. There are calculated tables cannot reference any data in your Direct Lake tables, and the calculated columns are still in preview and are not materialized and are not yet available globally. If you're working with Direct Lake, you should be aware that there are those two different versions of Direct Lake models. On the one side, there's the Direct Lake on one lake, which connects directly to your Delta tables. on Direct Lake on SQL endpoint, you're always using the provided SQL endpoint of your lake or warehouse. This introduces another logical layer, which can introduce complexity, but it also provides the possibility that Power BI can fall back to DirectQuery if you're hitting any of your Direct Lake limits, which are defined by your capacity. We sorted that type of model out of our suggestions because we didn't see any improvement about an import model. As I mentioned before, we do not think that we hit any of the size limitations in import mode. So that's more or less, with that we have covered the base models. And now let's move on to the composite models. If base models are about choosing one approach consistently, composite models are about combining approaches where it makes sense. Their motto is basically better together. With composite models, you can combine import a direct query, multiple direct query sources, import a direct lake, or even different semantic models together. So let's go through these scenarios one by one, starting with the classic combination of import and direct query. In this composite model, some tables are imported and some tables stay in direct query. That means you can use import mode for the majority of your model and still bring in selected data in real time. As we have seen before, the architectural components do have different roles in import and direct query mode. Therefore, we do see two ways in this picture. In the upper area, we see the process from an import model perspective, whereas the perspective of the direct query model is drawn at the bottom. Both patterns can exist side by side in one semantic model. This is what makes it this type of model, or all composite models, quite powerful. This model type is the only model type where a table can be of the storage mode dual. When a table is defined as dual, it will be loaded into the Vertex engine during the refresh of your semantic model, but Power BI is also aware that this table can also be used for direct query. So in a way, it exists in two different modes in your semantic model. This option is only available if the import data source and the direct query source are the same database, same server. By using dual mode, we are giving Power BI the flexibility to decide if the query should be executed in Vertex or in direct query engine, and can therefore use, in both cases, regular relationships. Of course, we have to be aware that all direct query limitations still apply to the direct query tables. And the most common use cases for this type of model types are write-back scenarios, or if you have to overcome size limitations within the Power BI Pro workspace, then you could use aggregations to mitigate that. As I mentioned before, direct query can only serve on one data source per model. Therefore, you have to create a composite model if you have to combine multiple data sources in your model and you cannot import them. At a first glance, this might look like a normal direct query model, but technically, it is a composite model since you are creating multiple source groups within that semantic model. And as soon as you combine more than one source group, even if both databases sit on the same server, you introduce all the implications of limited relationships between those source groups. What a multi-direct query composite model defines is the fact that the tables do come from different direct query sources. And this type of composite model shares, of course, because both are using DirectQuery, shares a lot of the base DirectQuery model. The data still stays in the source system and it is always up to date. Due to the additional performance penalty introduced by the limited relationships, I usually recommend to check if you can push the linkage of the data back upstream somehow with using a linked server and doing a view in one database so you can access everything via one database. Import, the composite model that combines import and direct link on one lake, is the newest composite model type available. It was announced in preview last year and reached general availability this year in March. From an architectural perspective, the data sources still have only the task to provide the data during load time. If the table is connected via import mode, Power Query reads the data and it will be stored in Vertepack engine. If the table is used in Direct Lake, then the tasks of reading the data and transforming and storing will be covered by Fabric. And within the analysis service engine, only some metadata will be stored and cached. The really cool thing about this solution is that everything stays within one source group. That means you do not introduce a limited relationship. Even though, from an architectural perspective, it sounds as if you are combining different storage approaches. From a Power BI point of view, it behaves as one data store. That's due to the fact that Direct Lake or the delta tables in one lake can be read by the Vertepack engine natively. That gives this model a major advantage. It performs the DirectQuery performs all the queries in one area. Of course, all Direct Lake limitations still apply to the Direct Lake tables. But overall, this is a very promising model type, especially when you want to combine flexibility with strong performance. It enables you to work with huge fact table in one lake while importing the dimension tables as you are used to. Even though they are now rolling out the calculated column feature, it can still make sense to add your calculated columns to an imported table due to the flexibility and the fact that in the import mode, the calculated columns are materialized. Now, we come to the final composite scenario. It's DirectQuery for Power BI. In this architecture, the data sources are already existing semantic models, which are now linked together in a new semantic model within the analysis service engine. Similar as in the DirectQuery model, Power Query only acts as an exchange interface to the source semantic models. The source semantic models do most of the heavy lifting. They do the preparation and so on and so forth, and the connection to the real base data. They provide the data prepared and calculated. The new model then connects to them and builds on top. That makes this approach very strong from a reuse and maintainability perspective, which marks it as a good candidate for our project. Because what I missed to say at the beginning is we had to combine already existing KPIs. So in different models, we have already defined all those KPIs which we needed for the new solution. And therefore, we thought, okay, that could be a pretty good thing to do. Despite the most obvious benefit in this type of model is that you gain a lot of maintainability. You do not have to maintain many different versions of the same measure in different semantic models. There's also the benefit that you can add further data, which makes it, in my point of view, a perfect candidate for some sort of curated self-service solution. On the downside, you have to be aware that all your users have to have read permissions on all connected models, on all referenced models. You also have to be aware that the security restrictions of your source semantic models are applied, and there's no chance to use a fixed identity to overcome that. And of course, the performance can be an issue, especially if you're using limited relationships with a high granularity. Before we talk about which model type fits which scenario best, let's take a comparison of the base storage modes, import, DirectQuery, and DirectLake, as they have a significant impact on how a model behaves. Security-wise, the main difference is that you are able to leverage your data source security in DirectQuery and in DirectLake. Of course, in DirectLake, which is defined in Fabric, not really what's defined on your base source. But you can use semantic model row-level security in all three of the storage modes. But please keep in mind that you should stick to one security layer and do not mix it up. So do not use data source security and put some semantic model security on top of it. You will get confused by it. From a refresh perspective, DirectQuery is the most simple one, since you do not have to think about a refresh strategy. It's up to date anytime. For DirectLake, there's an option to automatically trigger a metadata refresh when new data arrives in your connected OneLake files. So in that case, at least your Power BI model is always in sync with your OneLake. Of course, you still have to transfer the data from your data source to Fabric, but you can do that with in different ways and in a high frequency. In import mode, you have to schedule a refresh or trigger it manually or trigger it by your ETL process. And then it starts to load the data into your model. And depending on how much logic you put into that and how big all your tables are, that can take some time. Import mode stores the data in the Verteback engine, and DirectQuery doesn't store the data at all. For DirectLake, the data is stored in Fabric. But as I mentioned before, that can be read by the Verteback engine natively. Therefore, there isn't much of a difference between DirectLake and import mode from an end-user experience. Import mode offers the widest collection of supported data sources. This is tightly followed by DirectLake, so they're not quite in sync, but close to. And DirectQuery is very limited in that area of possible data sources. It is more or less restricted to relational databases and some multidimensional databases. But if you think about structured data in Power BI, those are the most common data sources, at least in my field of work. With respect to features, import mode beats the other two one by far. You can use all DAX functions. You can use calculated columns, calculated tables, hierarchies, everything. In DirectQuery, you do have a limited set of DAX functionalities, so not every DAX function is available there. And in Direct Lake, you have the constraints on calculated tables that you are not allowed to, that you cannot reference or use any data which is stored in a Direct Lake table. So you can just build your own calculated table by a DAX function. And calculated columns are just rolling out now, but they are unmaterialized, and therefore every time you touch those calculated columns, they have to be recalculated again and again and again. And what's easy to oversee is that Excel hierarchies are not supported by Direct Lake so far. The last difference I would like to point out is in which workspace types or which workspace type do support which storage type. DirectQuery and import mode are supported by all workspace types. So you can use a Power BI Pro workspace, a Power Premium per user workspace Premium, or Fabric F64 Plus, or a standard Fabric capacity below F64. For Direct Lake, you have to use a Fabric capacity. It doesn't matter on which size you are using, but it has to be that workspace has to be backed up by a running Fabric capacity. So that brings us close to the end of the presentation already. And now let's talk about which model I recommend you to use in which scenario. Let's start with DirectQuery. In my point of view, DirectQuery is probably the best model when it comes to data freshness, especially if you're working with on-prem data sources. It will get you as close as possible to real-time reporting, but you have to be aware that you will pay a price in query performance. Direct Lake gives you a strong balance between data freshness and performance, especially if you can use something like mirrored databases, or can use mirroring, or any other sort of high frequent data update in your data lake or in your one lake. If your data already lives in one lake, like it's some sort of collecting your own logs of your workspaces, this approach could even outpace DirectQuery due to the improved query performance in effect of the full point when is the data available, or when is the data created, till when it's presented to the user. Import and DirectQuery, I've already mentioned it before. It should be used if you would like to create a planning solution, or if you have to overcome any size limitations, especially if your solution is hosted on a Pro workspace. Regarding a planning solution, there's now Planning IQ also announced as preview in March, which can be an option if you are using Fabric for planning in the future. But as long as you stick to a Pro workspace, this is the way to go to enable some sort of write-back planning solution. Import and Direct Lake as a composite model can be used again to overcome size limitations of an import model if you are using a Fabric workspace. And it makes sense to use it if you need the flexibility of import mode over a Direct Lake model, like adding a calculated column which is materialized to your dimension for getting price ranges or something like this. Then this model can be quite powerful. DirectQuery on Power BI should be used if you would plan a curated self-service scenario where the user should be enabled to even enrich the data or enrich the existing models with their own data, then this is the way to go in my point of view. If you also if you think about the cross-model reporting, this is a quite good option. If you can manage to create your cross-model relations on a low granular dimension, this can be performed pretty well, and it avoids a maintenance effort you won't be able to manage in the future. If you haven't found your model type yet, go for input mode. Input mode is, in my point of view, the best in query performance, most flexible solution, and therefore use it as long as you do not have any strong arguments against it. Because it's simple, it's used, we are used to it, let's be honest. So what meant that to us and the discussion or the project I've mentioned at the beginning? We decided to go for the composite model in DirectQuery on Power BI. We decided for us, we do not see the possibility to cover that overhead and maintenance burden, which is putting how should we synchronize all the measures between all those different semantic models, especially if you know that the models in question are implemented by different teams. So there is always the chance that someone is adding a new measure or changing the calculation of a measure, and we would not be aware of it at the beginning till someone is telling us, hey, you are showing a different number than the other report. And we would strongly avoid that. Furthermore, we were pretty sure that the dimensions we are using to combine those semantic models are of a very low granularity. I'm talking about 50 plus elements per dimension. So that shouldn't be an issue. And with that, it's already time to go to the Q&A, and let's check if there are any questions so far. Otherwise, here are the QR code so that you can download the slide deck. And yeah, let's open up the discussion.